Okay, let's look at some more examples, addition and subtraction of rational expressions. So since they have different denominators, I'm going to need an LCM. And in this case, I see a factor of x, and the highest exponent I see is 2, so the LCM must be x squared. Now the first denominator already looks like the LCM or the LCD, so I don't have to do anything with that. The second guy, I need to multiply top and bottom by x. Once I do that, I really have the same denominator for both of them, so I can do my check because they're both x squared, and I can worry about subtracting the numerators. However, I must do order of operations, which means multiply first. So this x gets distributed into both of these, and be careful, there's a minus in the middle as well. So I'm going to be very careful, and I'm going to say, well, that's going to give me an 4x squared and a minus x. However, that minus is going to apply to everything. So I'm going to put it in parentheses and I'm going to carry down the 2. So I will distribute the minus shortly. For now, all I've done is distribute the x from the back. That's going to give me 2 minus 4x squared plus an x all over x squared. In descending order, negative 4x squared plus x plus 2, positive and positive, all over x squared. And we try to factor the numerator to see if anything further reduces, and we can't. So since we can't factor it, this is our final answer. And again, I cannot cancel this x squared and that x squared because that x squared is multiplied with a negative 4, however added with all these other links together. Let's go to part B. I need to get my LCM, and in doing so I have to get a common denominator, or least common multiple. This is not factorable, the first denominator is, so I'm going to pull out a 2 and I'll be left with b minus 2, which means my LCM must contain a b minus 2 along with a 2 as well, because that's 2 times another factor. So the first denominator is fine. The second denominator is going to need a 2, to be multiplied bottom and top. I'm doing this a little bit differently. I'm putting the 2 in the front as opposed to the back like I did here. I want you to see it both ways. So now the denominators are the same. Check, check. And I have the same denominator, 2 times b minus 2. And again, I have to be careful because there's that minus in the middle. And this time I'm going to treat them both together and say I'm going to make this negative 2 distribute into both of them. So I'm going to get the b that's just going to carry down as is. And negative 2 times b is negative 2b. And negative 2 times negative 1 is a positive 2 when it gets distributed. So in this previous one, I distributed the x from the back, and then I made sure I distribute the negative 1 from the front in both of them. In this example, I chose to put the 2 in the front right away and make it a negative 2 to distribute on top for both of them. Now I'm going to combine like terms, and that's going to give me negative b plus 2 all over 2 times b minus 2. And this is an interesting one because this guy almost looks like the denominator, but they're sort of switched in sign. B is a negative b, and negative 2 is a positive 2 here. So what I'm going to do here is I'm actually going to go ahead and factor out a negative from the numerator. So when I factor out a negative 1, this is going to switch into a positive b, and the second term is going to switch into a negative 2 all over 2 times b minus 2. Now notice these are products, and since they're products and common factors, I can make them go away, so I end up with just a negative 1/2 for my final answer. Alright, let's subtract these two, which almost look like they have the same denominator. So I can choose the LCM to be x minus 1 or 1 minus x, because if you recall from before, these are just opposites of each other. They're pretty much the same thing with opposite signs. So if I say I want both of them to look like an x minus 1, what I'll actually do is I'll go ahead and multiply either top and bottom of the second one by -1, or maybe I can factor a -1 from the bottom. So here's what I mean. I'm going to keep this guy as is, and I'm going to change this guy to look like the first case, x minus 1. So in doing that, I'm going to actually factor out a -1. And when I factor out a -1, remember it switches the minus x into a plus x, and it switches the 1 in the denominator into a minus 1. Just like we did up above here, factoring a negative out switched both of these signs into a positive and a negative. Down here, factoring a -1 is going to make this a -1 and make that a positive x. Now what I'm going to do is, since a negative and a fraction can go in the middle or upstairs, so if I have like 2 over -3, that's the same as -2/3, which is the same as -2 over 3. So again, a negative and a fraction floats. It could be in the bottom, it could be in the middle, or it could be in the top. So I'm going to take this negative and maybe put it in the middle. So when I put it in the middle, I'm going to have 2 negatives, which make a positive. And here's my new problem that has the same denominator. So I end up with x minus 1, and I can actually combine these and get a 5 in the numerator. So that's case 1 if I want to keep the denominator to look like x minus 1. Now let's go look at the same problem another way. Maybe we can do it here on the side. Let's say this time I want the same problem, 3 over x minus 1 and 2 over 1 minus x, but I would like to keep the denominator to be this guy, and I would like to change this guy to make it look like the other one. So this one I keep, it doesn't change anything there. This one I'm going to factor out a -1, and that's going to switch the order and the sign, in other words, so that's going to make it a +1 and a -x, and then I have a 3 here. And what I'll do is I'll take this negative and make it float upstairs. When I do that, I end up with -3 over 1 minus x minus 2 over 1 minus x, which is going to give me my check common denominator. And I can actually combine the numerators. -3 and -2 is -5. This is another acceptable answer. So I either have the opposite, the negative, in the top like I do over here, or I have the negative gone and sucked into the denominator, which really has the order of x and 1 reversed. Here you have 1 minus x, here you have x minus 1. Alright, last one. They all have different denominators, so the LCM or the LCD is going to need to have the first factor, t minus 1, the second factor, t minus 2, and also the last factor, which is just t a monomial. So all three are different factors. I need to account for all three of them. Now the first one is missing 2 items. It's missing the t on top and bottom and the t minus 2. So I need to multiply by 2 missing items. Same thing here. I need to multiply top and bottom by t, and also with the t minus 1. Last one is missing the 2 binomials, t minus 1, t minus 2 on top, t minus 1, t minus 2 in the bottom. So it's a little bit busy because each term was missing more than 1 item. Next, I have the same denominators, check, check, check. So I got this big old thing, t minus 1, t minus 2. That's the same for all of them, and I have to clean all of this up. I have to add them, but I must multiply, then add. So in order not to make mistakes, let me write it like this. I have 6 in t, and then I'm going to be distributing that into t minus 2. In the middle term, I have 2t, and then the t minus 1 that I have to take care of. And in the last one, I really just have a 1 for the coefficient, which doesn't really change much. I have t minus 1, t minus 2. So at this point, again, these are the giant links, and I cannot add them unless I multiply first. So make sure you don't do any canceling from the numerator and the denominator, because these are all linked together. I must multiply each item and then see what I can do. So we end up with 6t squared minus 12t plus 2t squared minus 2t plus a t squared minus 2t minus 1t plus 2 all over my denominator that contains 3 factors. Now let's go clean this up. So it looks like I have a 6t squared, a 2t squared, and a 1t squared. That is 8 and 1, 9t squared. I have minus 12t minus 2t, that's minus 14t, and then another minus 16t, and then another minus 17t. And then I have this last guy, positive 2, all over t, t minus 1, and t minus 2. And then we're going to try to factor the top to see if any cancellation happens. And in analyzing it on the side, we actually figure out that we can't factor this, so this is as far as we can go with this problem. Even if I try the wow method, I'm not going to be able to get a product of 18, it looks like, and a sum of negative 17, because both factors will have to be negative. Okay, a quick example with rational functions with function notation. So remember, the x is the input for both of these functions. We're looking at f of x and also g of x. Both of them pull this x, and the operation that we're going to do is add the two functions. So my first function is really just 1 over x plus 1. My second function is just x over x plus 1. And I'm going to add these two. And luckily the denominators are the same. Check, check. So that's going to give me just the numerators to combine. And when I combine those, I get 1 over x. But 1 over x is the same as x plus 1, so it looks like they're both identical and they reduce. So my final answer in adding these two fractions is equal to 1.